Hello and welcome. It's been about 6 months since I made a video. Got home from Thailand a couple of weeks ago and been getting things, organized again. And figured I'd come down here and try to churn out a video. It's surprising how hard it is to get back into the swing of things when you've been away from it for 6 months. Just figuring out how to get the camera working right. Took me 15 minutes. TESMEN sent me a clamp meter, AC/DC clamp meter, 300 amp. It'll do AC amps, DC amps, and then voltage, continuity, all the rest of the stuff. And I figured it might be interesting to take a look at it and compare it to my triplet. Of course, this is a 1000 amp DC AC range meter, and my little Voltcraft here. Now this is only 100 amp, but this is my go-to 99% of the time. I like this one so much I bought a second one. I did a video on this quite a while back, and this thing is accurate even with just using the clamp on method. At low DC, it's got a 2 amp range. It's accurate down to the milliamps, down to a milliamp or so. I use this all the time when I'm working on my antique radios to check the B+ draw, and I have one in my travel bag for on the road. It's just a handy, convenient little meter, and when I go to the flea markets and so forth, I carry one of these with me. It's got the voltmeter. It's got everything you need to check stuff out on the road. But it's limited to 100 amps, and I had picked this up a while back because if you're doing any automotive work, you want to look at the current draw on a starter, so on and so forth. You need something that's more 100 amps than this thing's 1000 amps. It's got a 600 and 1000 amp scale. And then there's this one, which is good for 300 amps. And I figured this would make an interesting comparison. How it compares price-wise, feature-wise, and so on and so forth. And opening the box here, it comes in a nice little case, and it's actually got a nice looking manual. Now this is in several languages, but in comparison to the paper books that came with the other two, it's kind of nice to see a real manual come with something. Supposedly this has batteries and everything else with it, so we'll open this up and take a look. And still sealed in its package here. So let me get batteries in this thing. There's the batteries for it. There's the test leads. Oh, this does temperature, as does the triplet. It's got a temperature probe here that came with it. Let me get this thing up and running, and we'll take a look at the features and see how it compares for accuracy against the other two. And since this came with Duraleaks, I'm going to check these before I even install them. Okay, that one's fine. This tests them under load. It has a load setting on it. And these look good. I have bought packages of Duracell, brand new, bring them home, set them on the shelf for a week, and 2 or 3 of them were leaking. And I've had that in all sizes, AAA, AA, and D cells do that to me over the years. I used to swear by Duracell, now I swear at them. It's just inexcusable. Just inexcusable how bad. In fact, I've opened packages of brand new Duracells and had a couple of them dead in the package, and they were dated for another 10 years out. It's a sad commentary. Oh, sounds like it powered up when I dropped the batteries in here. And we'll stick the screw back in. This unit runs on 3 AAAs. Oh, nice display. I'm really happy with that display. They say it's an LED, but boy, that sure looks like OLED. This unit, like I said, 3 AAAs, the triplet uses a 9 volt, and the Voltcraft here uses two AAAs, two AAAs, a 9 volt, and three AAAs. But boy, I am really happy with that display. This has a backlight, as does this one, and this it's obviously an OLED display. It really is a nice looking display. Function auto, it's got a function. This is automatic, where these have to be set manual for the range. This is automatic. It's got an inrush. It'll remember inrush current. It'll remember max min. One nice thing about this, and I'm not even sure how to do it. Let's try this. Nope, that shut it off. It's got a flashlight built into it. And if you've ever worked in a dark panel without a, you want your hands free to be doing things, you don't want to be trying to hold a flashlight and operate the clamp meter. Neither one of these have a flashlight in them. This is kind of a nice feature to have in a unit. This is a 6,000 count meter, as is the triplet. The Voltcraft is a 2,000 count meter. Now, when I bought the Voltcraft, this was about $36, and at that price I bought, when I found out how accurate it was, I bought a second one. They have since increased their price dramatically. The cheapest I can find, the Voltcraft now, is $115. They have gone up considerably now. Is it worth $115? I'd be happy at the $50 level. I mean, I'm perfectly happy with the meter. I love the little meter, but $115 seems a little pricey. The triplet I can find for between $70 and $109 online. If you want the NIST version, they have one that's traceable back. You can get a certification for it, and it's traceable back to the Bureau of Standards. That one's $183. Where the TESMEN here, did I say TESMEN? I meant Voltcraft over here. The TESMEN is a very reasonable $49.95 or $50. That's a good price for one of these. AC and DC amperes, AC and DC amperes, AC and DC amperes. But for its price class, 300 amps AC and DC, 6,000 counts. Now you can get an A model. This is the D model. You can get the A version of this, which only has AC amperes, and that's available for $29.99, around, let's call it $30. This one's $50 with the DC. All three of these have the non-contact voltage check. Let's see here. Put the function, and I'm going to have to figure out how to drive this thing because no, that's not it. Oh, NCV Live. There we go. Okay, as I was editing this is a couple days later, I realized that when I was doing the non-contact voltage test, I should have included the TESMEN dedicated non-contact voltage meter or indicator. Given a comparison between that and these other units. Now, I know the guys out there are going to be yelling at me. You should always use a voltmeter. I get this every time I talk about using one of these, and they call it the death stick and so on and so forth. Don't even bother, okay? I know. What you should do is always verify your equipment, whether it's a voltmeter or one of these voltage indicators, on a known live circuit before you trust it on anything. I can't tell you how many times I've been out in the field with somebody who's got a voltmeter banging around in the bottom of their travel bag, and they grab it and they say, oh, this circuit's dead. And I say, you haven't tested it on a live circuit, on a known live circuit. And sure enough, their leads are broken because the thing's been in the bottom of their travel bag and they've been running around, oh, look, this isn't live. Verify your equipment, okay? Whether it's a voltmeter or one of these, verify it before you trust it on a known live circuit. Now, having said that, this unit has two sensitivity ranges. This is the little TESMEN, what's the model number? TN213. And they gifted me a couple of these a couple years ago. And this has been in my travel bag ever since. I'm going to get in, this is 120 volts. And I'm going to get within, okay, that's almost 2 inches. Now this has a low sensitivity reading or range. I can put it on that, and it has to be a lot closer before it recognizes the voltage. But in the high sensitivity range, this is 12 volts. It'll detect 12 volts AC. And I've tested this on thermostat wiring, the 24 volts AC. It finds the live ones every single time. But on 120 volts, I'm almost 2 inches away from that cord. And this, I can tell what side is the hot side versus the cold side. Hear the difference? The slow beep. That's the hot side of that wire. You can tell the difference with this unit. Okay, so 2 inches with a dedicated unit. This is their clamp amp meter. And okay, this goes through a self-calibration routine. Now that it's calibrated, we're going to go up here to the non-contact voltage. Okay, do it again. Just come in slow until it finds it. That's somewhere around ½ an inch. Okay, where that other unit was 2 inches. Somewhere around ½ an inch it detects the live wire. The little volt craft here, turn it on. Let's see what it comes on. Okay. That's 1.5 inches. That's not bad. And then we have the triplet, and we'll put that on. Just turn it on volts, and it's automatically using the non-contact. Now you get a lot of false blinks with these when they're moving and waving around. But if you get them close, let's see here. Okay, this appears to be the worst of the lot. This has to be about 3/8 of an inch away from the wire before it comes on. So this is actually the least sensitive of the three of them on the non-contact voltage detection. Alright, figured I'd throw that in so we had some hard data on how close or how far away. This is the hands down winner. This one's not too bad. This would be, you know, this is like 1, 2, and 3 as far as sensitivity on the non-contact. But again, always verify with a known live circuit before you trust any of these, including this one. Okay? And one more thing I forgot to mention. On the little TESMEN non-contact AC voltage detector, easy for me to say, this also has a built-in flashlight, which again comes in extremely handy. You've only got to carry one instrument with you when you're poking around on a wall or looking for that thermostat wire. And a handy little unit. I can't thank TESMEN enough for this. I mean, just I've enjoyed using this now for a year and a half. And I've fallen in love with this OLED display that's on this unit. Okay, enough said. Okay, as Dave at EEV blog would say, I had to RTFM to figure this thing out. I was trying to figure out, a lot of times you just hold the on button down to turn the flashlight function on, but that's not the case. There was a button over here that I didn't spot, and that's the hold data. You can get a reading and hold the data, or if you hold it down, the flashlight turns on. Hold it down, flashlight turns off. You click it quickly, one briefly, the hold data section, the hold data indicator comes on. That turns it off, and you can see it's sweeping through the auto function. if you hold the auto function down until that, come on, why isn't that working for me now? There we go. There's amps, volts, ohms, continuity, diode test, millivolts, frequency, capacitance, temperature, centigrade of Fahrenheit, and non-contact voltage test. And then if you give it another quick, it goes back into the automatic mode so that it will automatically select the proper function. So let me move over to the DC test, and let's see how these things compare. Okay, we've got a Hewlett-Packard supply here that is good. I'm going to turn the current down. I can set this to constant current all the way up to 20 amperes. And we've got some number 10 wire here across the output, so I can check the DC current reading. I am not going to, or I don't expect to find down at the low amp settings that it's as accurate as this is, because this has a 2 amp setting, and like I said, it's accurate down to the milliamp range, 1 or 2 milliamps. These I would not expect to have that kind of accuracy, but perhaps they do. We'll do some testing. Hang on a second. Alrighty, I'm switching back to the old camera for a bit here, even though it has some autofocus issues. It has a better field of view, for one thing, and two, it's easier to remove. I can, while it's on the tripod, I can remove the memory card, where on the other camera I have to take it off the tripod every time I want to access the memory card. So just for a short while here, we're going to use the old camera. We'll see how it looks compared to the new one. Alright, I'm going to turn on my power supply, and I have it set up here for 1 amp indicated on the analog meter. Now, how accurate that is, I really don't know. We're just doing an A-B comparison here. I know this is accurate. So I'm going to put this excuse me, on the 2 amp range. And now I forgot to zero it. I got to go on DC, and because the Earth's magnetic field affects these, you have to zero them. And then I'm going to clamp it on here. And this is saying, well, it should be up here in the end. That's saying 944 milliamperes on that unit. So let's turn this guy on, and it should be auto. So let's see what it says. And it says 1.03 amperes. Now, if I'm going to manually just set it on amps. There we go. Oh, did I zero that? Okay, we've got to zero it. Again, I've got a RTFM here. Min max. No. There we go. That zeroed it. Why? Oh, that set it on AC. Okay, I'm going to function again. Not sure how to. There's DC amperes. Oh, that's AC. AC, DC. Alright. Yeah, again, 1.03 amperes. And let's see how this one fares on its lowest range. Set relative. DC amperes. And that's reading 800 milliamperes. Or 80 milliamperes rather, which doesn't surprise me. Now it'd be 800 milliamperes. 800 milliamperes, I'm sorry, 800 milliamps. And it doesn't surprise me that this one isn't reading accurately down at that range, it wasn't designed for that. It's an industrial meter, where this one is, and if I get it back on DC, almost an amp, but I didn't zero it, so let's zero it. Alright, we'll go back and try again. 944, same reading I had before. So this is by far, at that low setting, the most accurate. This is close enough for general use, 1 amp. And this one is, you know, not much good at that current reading. It's reading 800 milliamperes. Again, not surprising. So let's shoot this up to, let's go to 10 amps. 8, 9, 10 amps indicated on the analog meter. Put this on the 20 amp scale, DC, zero it, and it's reading 9.85 amps, 86 amps. This one's reading 10.44, close enough for most people. And this one, let's see here, we go relative. That one reads 10 amps, 10.1. So once you start getting up, see 9.86, once you start getting up into the higher ranges, this is going to do a better job, or a more accurate job. Let's run this up to 20 amperes and see how we do. 19.5 amps. I'm expecting this to do fairly well. 20.6 and 20.2. So these two are in pretty close agreement. Once you start getting up above the milliampere range, you know, again, this is designed for low current setting, for low current ranges. And I gotta go DC again. Yeah, because I changed range. So 19.4 on the 100 amp range, 20.6 and 20.1. Close enough for, you know, general checks. What I think I'll do now is I might go out to the car and do a couple of inrush tests on the starter motor. I won't bother using this one because this one will be way out of range. But I will go out and try this one and this one on an automotive starter and see what we get. Okay, I think I'm going to have to wait on the inrush or high current reading on the starter motor until tomorrow or another day when it warms up a little bit. The wind is howling outside and temperatures drop down to under 40 degrees. It's pretty damn chilly out there. And we'll wait for tomorrow. Actually, this weekend's supposed to be up in the 80s. So we'll take a look at a couple other things here while we got on the bench. I've got a little voltage reference here. It's just a little Chinesium tester. But I have verified this against my Fluke 8810A, which was calibrated a short time ago. And this says 9.777, and the Fluke agrees that it's 9.7774, I think it is. The numbers on here are right on the money. It's very accurate little voltage reference. I forget what I paid for that. It wasn't a lot of money. It was pretty cheap, but it's very accurate. You can run it on a 12 volt battery or an external 12 volt source. So right now it's set for the 9.977. Did I say 777? 9977. Just under 10 volts. So we'll turn this guy on. Oh, before we even bother with that, the leads on the little Voltcraft here have the little, you know, you can shield them, or the point sticks through. It gives you, you know, the opportunity to get in between something without short circuiting. Not extremely sharp. I wish they were a little bit. I like the needle sharp probes myself, but they're not bad on that one. The Fluke, oh, and these are PVC, as is the Fluke They're not horribly stiff PVC, but they're certainly not the nice silicone leads either. The fluke, you don't have the option. I could trim the end off of these, I suppose, and just expose a little bit of the tip, but these have full protection on them, protecting, you know, the so-called sharp points, but these aren't terribly sharp either. What I think I might do at some point is just trim the tips off of these, so when you can get in, be protected except for the very point. And the TESMEN has the same, these are the same quality leads as on the flute or the triplet. They're PVC, but not bad, not extremely stiff. It does have the caps that allow you to use the probe tips, or you can remove them for inserting them into, you know, plugging them into like a terminal strip or something. The downside is, TESMEN, pay note to this, the jacks are not color coded. Now, usually you have the black for the common, and usually that one's red for the input, but you know, they're marked here, but it's not intuitive. You have to go looking for the marking on it, where the triplet has a red for the red lead, black for the black common lead, and the same thing on the Voltcraft. Small detail, but it would be nice, you know, that's something that they could think of on their next revision, perhaps, if they make a C model, is to have the red for the red probe. 99.999% of your test equipment is set up with the two colors. Okay, let's turn this on. I don't know if we are going to be able to see this or not and read it. Maybe you can, if I get the leads turned around here. Yeah, hopefully that's readable. I can't tell in the viewfinder. We're going to test the 9.977. Zero, let's see if it zeroes out. It does. Oh, I'm on AC, dumbass. Okay, there's DC. Let's see if that zeroes out. It does. And that says 9.97. And this is 9.977. So I'm surprised it doesn't read 9.98, but it's reading the first, you know, it's reading the first three digits on the money, and that's me moving around here. 9.97. Now that it's stabilized. So pretty darned accurate. This little guy is really on the money here. Let's take a look. See if we can stand this up somehow. Hang on a second. Alright, you'll have to tip your head sideways to read this one. I think it's visible. There it is. Yeah, I can see numbers in the screen here, so you should be able to read that. Make sure this zeroes out. And this sure takes a while to count down. But they are DC volts, it's zeroed. And again, we're going for the 9.9777. And this is reading 9.93. So it's reading, the triplet's reading a little bit low. Should be 9.97, it's 9.93. Within its spec, you know, you can't fault it. It's not designed for laboratory work. And then now let's take a look at the TESMEN. Turn it on. And to be fair, I am going to put this on manual so that it's not trying to auto range. It's on DC, reading 0 volts. Wish I could stand that up. Oh, I think I can actually. If I do this, clamp that in there, stick that. No, maybe not. Okay, there we go. Nope, the light's on it. Let's see. Let's see. Try a different angle. There we go. You can see that one all right. And again, we're on the 9.9777, or excuse me, the 9.977. Too many sevens. Let's see what we got here. Let it stabilize. 9.96. Not bad. Not bad. Close enough, within specification for sure. Close enough. Okay, let's get the DC thing out of here, and let me use my fluke to check my line voltage, and then we'll set up and test these to compare it. Okay, my fluke says we have 119.1 volts AC today. It fluctuates between about 128 and 117 depending on the time of year. But get under here to the outlet and see what this one tells us. This says 118.7. Not bad. 118.8, almost 119. So it's reading a little bit low, as it was on DC, but certainly within its published specs. Let's try the other triplet here. We'll put this on volts and mode AC. And make sure that there's no reflection. I think you can see that. I hope you can. Put these probe tips back on here before they get lost. Swept off the table. Okay, we're on volts and AC. 118.1. So that's reading about a volt low compared to my 6-digit fluke. Alrighty. Let's see what the last little meter does here. Volts AC. Tip that up where you can see it. That readable? I hope so. It's hard to tell in the camera display, camera monitor. And that's reading 118.8, just under 119 volts. So this is the closest. Oh, there's 119. It's jumping around a little bit. 119. 118.9. There's going to be little fluctuations, but as I had stated when I tested this thing, it was extremely accurate, surprisingly accurate for, you know, what I paid for it. All right, maybe I ought to run a quick capacitance check on these. Let me get a cap down here. Okay, my Sencor capacitor tester says this 47 microfarad capacitor measures 42.8. Let's see how these stack up compared to the Sencor. And it's going to take this thing a minute. Most people are going to be using these for like air conditioner capacitors that are 50 or 100 microfarads. This says 42.3. What did I say the Sencor? 42.8 is what the Sencor said. So certainly good enough for checking capacitors like, you know, motor run capacitors and so forth. And this guy on capacitance, and let's put it on capacitance, auto, Fahrenheit. Oh, nope, wrong one. There we go. K ohms, volts, ohms, NanoFarads, there we go. Let's see how the triplet does. Can you read that? Hope so. I think I can see the numbers. The triplet says nothing. Try again here. There we go. Come on. Get on the leads. It's hard to hold the leads and the capacitor all at the same time here. And this says 2 point, oh, there we go, 44. Let it settle down. Okay, the triplet says 44.2 microfarad. Close enough to test a motor run cap. And let's see how this guy does. Turn him on. Come on, turn on. There we go. And I'm going to again manually put this on capacitance. There we go. Let's see what we've got. Wow, 42.5. Very accurate. Very, very accurate. Almost 42.6. It's climbing up here. 42.6. It takes these a while to settle down usually. These are not dedicated capacitance meters. This looks like it's going to climb right up and agree with the Sencor unit. So, very accurate on the capacitance. Now, when you get down into the 100 picofarad range, these aren't really designed to do that type of electronics work. So I'm just going to skip on that and not try to measure 100 picofarad cap. But for the work these are intended for, motor run capacitors or motor start capacitors, whatever you wish to call them, certainly up to the job. Very nice. I suppose I could go through and do the temperature stuff, but again, these aren't laboratory precision meters. They're going to give you a pretty good relative indication on temperature. I know the fluke or the triplet isn't all that accurate. I have dedicated temperature meters that I use. I don't rely on these for anything but quick checks. All in all, I'm pretty impressed with that for its price class, and I think I'm going to be carrying this one with me. I absolutely love that OLED display. It is just so easy to read, and for the $50 price range that these are available in, boy, hard to beat. Okay, I gotta hold it longer. There we go. Okay, we will go out when the weather's a little warmer. I'll add to this video. I'm not going to do it today. It'll be another day. It's just too damn chilly outside right now. But we'll go out and take some readings on the current, high current ranges of these two. This one's only got a 100 amp range again. Okay, there's another function that I missed or forgot to tell you about. When this is in the non-contact live position, and I'm going to put it up there manually, this is where you could use the non-contact voltage sensor, but you put a single lead. You put the input lead, no negative lead or no neutral lead, and you can detect that says H for high. That's the hot lead. And wrong one. And that says low. So that's your neutral lead. And that's your hot lead. It's a good way to check to make sure the polarity or the wiring is not reversed in your outlet. You can very quickly go in and check run around the house. Now they do have the little plug-in units that show you if your outlet is wired right, the ones with the neon lamps. But if you don't have that on in your kit, there's your high or your hot lead, and there's your low lead, just by using a single probe and putting it in a non-contact setting. It's another function on here. Now this is documented in their manual. There's nothing documenting that on this one, but if I put this one in the non-contact and do the same thing, if I go into the hot lead, there's a little bar graph here. It's full scale. And if I go into the neutral, you can see there's only occasionally a single bar shows up, and it says, out of range. So you can detect, there's the hot, and now I'm into the neutral. It gives me a brief 1 bar reading. On the live, it gives me a full scale reading. So it has the functionality on this one, it just isn't documented in the manual. The triplet, on the other hand, doesn't work at all. It detects both sides as being hot, and there's a very small voltage reading because it just doesn't have that functionality. It uses the AC setting for the non-contact voltage check, and I think it's just so if you're clamped around the wire, it gives you an indication that wire is probably live, but that doesn't have that functionality for the neutral. You can, of course, put this on your ground and go into the 2 lines and check, whether one's hot and one's neutral, but just being able to run around with a single probe and very quickly stick it in the socket and say, okay, this outlet's alright, that outlet's alright. It's kind of a nice, quick double check when you walk into someone's house and doing any electrical work. I cannot tell you how many houses here in New England that I have walked into that are wired reversed at the outlet. It's a frightening number of them that supposedly were wired up by professional electricians, and the wiring's backwards. It's frightening how many of them are off. Okay, I hope you can hear me over the engine. I wasn't very successful getting cranking amps, and I'll explain that when I get back inside. But we're looking at charging current. I'm looking at 32.6 amps here, 35.2 amps there, and 36 amps here. So this one's giving me the lowest reading. These two are in agreement, or pretty close, 36 and 36.6. Yeah, here I am holding the camera sideways like a real professional. But, so you can use it for charging, but I'll explain what the problem was with the cranking amp when I get back in. Okay, to sum it all up, I am very pleased with this TESMEN meter, as I was very pleased with their non-contact voltage tester. And again, I know people call them death sticks. Get over it. We had to pass on the starter draw test, and the reason being, on my Dodge, the triplet showed about 147 to 160 amps on the starting current draw. This one gave me an overload indication, so I switched over to the Ford, and the Ford was closer to 320 amps on the starter draw, which is kind of high actually. So I didn't even try it with this one because it would have been out of the range. Now what's going on here? You saw how slow this meter responded to both voltage, capacitance, and even current draw. It's a much slower responding meter. This one is an extremely fast responding meter, and that initial spike when the contactor first closes and before the starter even has a chance to start turning, you're going to have a very high current spike. This doesn't catch that. It catches the average current draw. This one catches that and goes into a protection mode and shuts itself off and says overload. Not a fault, it's just that this is a much faster responding meter. Can I recommend this? I can certainly recommend it for its price class. I know somebody out there is going to say you should have pulled like the fuse for the fuel pump or the ignition and tried, you know, cranking for a longer period of time. I didn't do that. My vehicle inspections are due shortly, and it takes my vehicles a long time to go through a full drive cycle and do the evap test. So I didn't bother doing that, but I can recommend this meter. I'm very happy with it, and again, thank you to TESMEN, and I hope to do some more tests for them in the future. That's it for now. I'm the Radio Mechanic. Thank you for riding along. Appreciate your stopping in and visiting. Take care. See you soon.